Okay, welcome everyone to this presentation, Multimodal Representations in Student Learning of Optics, Interdisciplinary Representation Construction Approach. My name is Li Hua Xu from Deakin University. Today, together with me is my co-presenter, Christopher Spent-Wine.
Hi, everyone.
So the study we're going to talk about in this presentation is part of a larger ARC project on interdisciplinary maths and science learning, or IMS learning. Here is a website if you want to explore a bit more about the project. So the aim of the IMS project is to deep student disciplinary learning through linking science and mathematics in meaningful ways. And we work together with the teachers in terms of collaborative design, planning and implementation of lesson sequences from grade 2 to grade 6. Some of the common features of those sequences including a strong focus on representation construction and mathematical modeling. There are opportunities for students to be creative and imaginative through inventing, revising and refining representations and data. There's a strong guided inquiry approach, which were featured in all the sequences designed and developed. We also follow a group of children longitudinally over 3 years period to investigate whether there's cumulative gains over 3 years. So in this study, we argue that the focus on representational construction and modeling can be considered as interdisciplinary practices that bring the two subject areas together, science and mathematics, in meaningful ways. It recognizes the importance of representation as tools for facilitating student understanding and learning, but also engage the importance of engaging students in modeling practices rather than just learning from established scientific model. So in this particular presentation, we are focusing on the topic sequence on light or optics, and our particular questions that we are going to address, including how do representations in science and maths intersect to support student exploration of the phenomena of light and reflection, and the challenges and the complexity that brought in terms of encountered by the teachers and students as they engage with this interdisciplinary approach for the first time. So the overarching research methodology underpinning this study is design, research and education. As we indicated, we work closely with teachers in the development, designing and implementation of the sequences through planning, meeting, team discussion, and so on. We video capture the lessons run by the teacher. We took field notes, and also we collected student work from the classes. As a team, we also drew on theory to discuss, debate and refine the different stages that featured in the sequence and the variations within those that the teacher followed. We come up with a pedagogical model which is into 4 stages that Russell Titler and Peter White had a separate presentation on this one if you're interested in the details of this particular pedagogy model. As you can see, it consists of 4 stages: orienting, posing representations, building consensus, and enriching and extending conceptual understanding. The particular focus for this presentation is on the unit of work, optics. As you can see from this slide, each of the lessons are designed to linking and connecting the science concept and math concept in meaningful ways. So our presentation will focus on the preliminary analysis of the 4 lessons on light reflection, including a design challenge of periscope. So the science focus is on light reflection, where the math concepts including the 2D and 3D shapes, and also the most important part is the concept of angle. So Chris is going to talk about some preliminary analysis of the data that we obtained from one of the schools, an independent school in regional Victoria. And the teacher there is a science specialist who teaches a grade 5 lesson, a grade 5 class. So I'll hand over to Chris to talk about the preliminary analysis of the student work and their interviews.
Thanks, Lewa, and thanks for the opportunity to talk about our research. Just to very, very quickly set some context in regards to the school, which Lewa has done. This was the first of 3 sequences that we worked with the teacher and this grade 5 class with at the school that we were working at. When it came to analysing the data, we used the framework that you can see here in this slide to look at both the description of what the students were doing in their work and how they were explaining it. So you can see the categorisation down the left-hand side as being not evident, beginning, developing, and consolidating. So when it came to analysing the work samples that we've taken from the 2 lessons on reflection and the 2 lessons on constructing the periscope, this is how we categorised and analysed, and it's the framework that we used to come up with what representations the students had generated in their work. So when it came to the reflection lessons, this and the next couple of slides are examples of the work that we saw from the students. And one of the things that Lewa will talk in the summary is the fact that the students that we observed were often just reliant on text, and this idea of representation graphically was somewhat foreign to them. And this being the first sequence of lessons that we had done with these students, this really came through, and you can see it in this slide what we're looking at is at a beginning stage, which is very limited descriptions of how light behaves and limited explanations of how light, object, and eyes facilitate seeing. So if you look in particular at those graphics, the drawings are quite simplistic, and as we move through the different levels of analysis, you'll see how we tried to categorise them. So that's beginning, but as I said, very heavy influence on the textual and simple graphics. So to the next slide. And here you can see where we've categorised and placed these students as being developing. So the descriptions of how the light behaves, the drawings are more complex. As you can see in the drawings on the left-hand side of the slide, we've got more representation of light rays using arrows. In fact, on both of the slides, you can see that they're far more complex in terms of the way that the students have graphically represented how light behaves. So that's developing. And then the next slide takes us to consolidating. And the detail in this, yes, okay, there's text in this, but you can see from the way that this student has used a light bulb to demonstrate the source of the light, the way that the light rays travel, there is more complexity, more detail, more sophistication, and it's a fuller explanation of the relationship between the object, eyes, and the light. So we class that as consolidating. Then we move on to the periscope lessons. And again, what we were looking for is the level of description of how light behaves and the explanation that these students gave. And I'll talk very quickly to the picture on the left. And one of the things that we picked up on the picture on the right, the periscope on the right, is the wavy line, that lack of clear definition around how light behaves in straight lines. And the periscope on the left has no examples of light rays at all. There is some maths there, as you can see, but again, quite simple. So on to the next slide. And we're starting to see in these diagrams more evidence of how light behaves. So the drawing on the right, we've got the straight line of the light moving through the internal workings of a periscope. And similarly, we've got a dotted line on the left. And on the left, you've got a top drawing, which is the exterior of the periscope, decorated, and the bottom is the inside. And then on to the next slide, which is consolidating. The explanations are represented in more detail. So you've got these stages of and levels of description of how light travels in more details as they get to consolidating. So there were some general examples, and we As part of the research, in this class of approximately 20 students, we had 6 focus group students. So we've chosen a couple of those students just to speak to and show you the examples of their work. And we had a pre-test and a post-test with this student, Jack. And the quotes on the left-hand side of the slide are from interviews that we did at the end of the sequence. So Jack was able to tell us at the end of doing that sequence of lessons that light can travel in straight lines when it hits water and go in different directions. And one of the tasks involved a laser maze where the students had to take a laser pointer and make that ray of light that's coming out of the laser pointer go through a maze. So you can see there the diagrams again. If I look at the one down in the bottom right hand corner, very simple. And this Jack we sort of categorized as beginning. Next slide. Charlotte, more advanced, and if you can see in the pre and post test, there's just that slight dimension of development in the very top drawing where you're starting to see arrows in the to indicate the directionality of the light. And as Charlotte told us, if there's something in a mirror, because the light goes onto the mirror and reflects, that's what your eyes see. Her periscope, okay, we'll say didn't work all that well, but you can look in there and light bounces. So you're starting to get with Charlotte that deeper building understanding of how light moves and how light works. Next slide. And Josh, again, if you look at the periscope in the bottom right-hand corner, you can start to see that representation more so in this diagram of how light makes its way through the periscope. And Josh told us that we learnt about light coming out of something, that the light rays, you draw arrows of where it's going. So the representation. He used a protractor to find out the angles when they were making the periscope. So there's that more sophistication with the mathematics. And he thought that the periscope was really cool because you could look around corners. Stan, again, even more complex. And you can see, this was one of the examples we showed earlier, of far more complexity in the pre-test diagram. Although what you are seeing when you get to the post-test is a deeper understanding of, rather than the light rays going in all directions, that more specificity. And with the periscope, a little bit more maths in there, but what Stan did tell us was, and demonstrate that deeper understanding, that one rule for light traveling, the incidence angle will always be the same as the reflected angle. And Stan was a boy that very much so was able to articulate clearly what his thinking was, but it struggled at times to actually get that documented. So he spoke about the visualization of what he was doing, and connected the work with picture storybooks.
I guess I'll take over from here. I guess one of the things I found interesting as we're going through those different examples is you can see the integration of math and science, whereas in the early examples where even though the student talk about the math, but it's not actually seen in the representations, whereas when we move across the different students, as in Stan's example, you can see that the math and the science, he kind of seeing a more connection between those two and be able to integrate those, the science representation and math representations in the drawings, as you've seen from those post-test and also the drawings there. So I guess we wanted to look at, from the teacher's perspective, clearly there's gains from the student representations. From the teacher's perspective, he also sees there's significant learning from the student in terms of the language they've been using. Because he's a specialist, science specialist for this particular class, he did not have the opportunity to teach maths to the students. So he did talk about the opportunity that he could actually teach them maths at the same time, which can strengthen the unit itself. He also commented on the impact of the maths and the way in which he used maths previously, which is pretty much about quantitative data collection, whereas he did see the opportunity how the maths works in the science sequence. He also commented on the representational competence that he did say that the student from, at the start of term, as Chris already mentioned, they often refer to or resort to the linguistic means of explaining and communicating. So there's a culture seem to be in that classroom in terms of try to write and wanting to write rather than thinking about how I could show the ideas or what I see in other forms of representation. But the teacher also, in the quote you will see here, recognize the importance of representation, which is not only for him to be able to see students thinking, but also for the kids to be able to unpack their thinking and learning from it as well. So the value of representation really coming out quite strongly from the interviews and also from the kids as well. So to summarize the presentation, that we can see there's some learning gains, I guess, in terms of student use of language and the representation that you see the integration of the maths representation and the science in the student drawings. There's also value attached to linking science and maths there, and also the value of visualizing ideas by both the teacher and the students. But we also admit there are challenges in terms of how we actually develop tasks that can link in maths and science meaningfully. In this case, I guess the light sequence that we presented to you provided us with the opportunity to really think about how the maths works and the science works together in this unit, and how they actually help us, help the student to be able to learn both in a very meaningful and deeper way. We do admit the challenges that associate with interpreting the meaning. We rely on the features of those representations, which I guess there's limitation in terms of data we had. So that's a challenge in terms of how we might be able to validate our interpretation of those representations. And lastly, I suppose the challenge of really introducing this interdisciplinary representation construction approach to the student, to the teachers, is that there's a strong culture in terms of writing and the linguistic means for explaining things and communicating things. So how we shift that mindset is something we are working towards, and hopefully by the end of the 3 years, some of the data that coming through the project are able to show that shift. If you have more questions or wanting to ask for more information, this is my email address. Please feel free to email us.